Hello everyone. Today I'm going to speak about the progress in my PhD thesis, Heart Rate Variability and Depression Patterns Across Health and Disease. This one, okay. My name is Shir Galin. I'm a psychologist and a first-year PhD student. My vision is reducing mortality and improving lives through psychology, and my mission is integrating psychological dimensions into everyday healthcare and policy. This fall I've started two projects. On both of them I'm going to speak up next. So the first project is investigating the accuracy in predicting depression through heart rate variability in a non-depressed population, which is a systematic review and meta-analysis. Depression affects over 280 million people worldwide and has substantial health and mortality risks. As you can see on the top right corner of this slide, suicide is the first cause of death in the ages between 15 and 29. And major depression actually increases suicide risk by 20-fold. Another small example is that the depressed heart failure patients have double the risk of dying within 2 years. That, in turn, costs a lot of money, and it burdens the economy with over $1 trillion annually. Our problem is that we have no biomarkers for depression, so we rely only on subjective measure to diagnose it. So if me as a psychologist want to diagnose someone with depression, I will just ask him, how are you? What is your mood? And it means that I have no early detection strategies. That also costs a lot of money. And as you can see on the bottom right corner of this slide, the direct medical costs are 150% higher for people with unrecognized symptoms of depression. However, we do know that heart rate variability, which is a cardiac measure, is lower in individuals with depression. So my aim is to investigate the relationship between heart rate variability and depression to enhance early detection and prevention strategies. Answering this question can have very good clinical implications that will help us guide early detection strategies. Our clinical question is, does lower heart rate variability precede depression in a non-depressed population? We are using the PFO model. The population is non-depressed, the factor is HRV, and the outcome is development of depression. Our hypothesis was that individuals with lower HRV have increased risk of developing depression. So the systematic search yielded approximately 18,000 results, and after screening them, we had 176 results for eligible for data extraction. The data extraction finished about 2 months ago, and we're now analyzing the data. Here you can see a forest plot of the correlation between RMSSD and future depression. RMSSD is one of HRV measures, and it's very widely used in the fitness trackers and smartwatches. Based on 5 studies and approximately 400 patients, you can see that the pooled effect size is minus 0.22, which actually means that there is a negative correlation between RMSSD and future depression. This correlation stays significant, although the variance is quite high due to different characteristics of the studies, like different follow-up times that ranges between 3 months and 3 years, and different comorbidities. However, we need to remember that we are interested in the prediction model of future depression. This is only a correlation. So we continued to analyze the data, and we encountered a problem. There was very high variance in the HRV measures, and it was very hard to pull that into a systematic meta-analysis. So we started a systematic review process with the goal of finding cross-study patterns and look at each paper individually. So what we found out was actually much more interesting than what we thought we will find out. Okay, so we found that the direct prediction of future depression by HRV is weak or inconsistent across studies. However, HRV has a very important role in the bigger picture of the prediction model. It acts like a secret ingredient, and the predictive power emerges under different contexts, like trauma, gender, or different parenting styles. So HRV acts as a shock absorber of the nervous system, but not linearly. So too little or too much of flexibility in the HRV might increase depression risks. So we hypothesized that we will find a very straightforward story. Okay? Lower HRV brings us higher depression at future time point. But we found that HRV and future depression risks has a U-shaped, context-dependent pattern. Okay, so low HRV, which is actually high fight or flight response of the nervous system, can be protective in chronically unsafe environments like toxic homes or chronic illness. Okay, and under the same adversity, like toxic homes or high chronic illness, we can see that high HRV, which is a parasympathetic nervous system response, the relaxation response of the nervous system, can increase vulnerability when is not adaptive to the dangerous situation. So our next steps were reaching out to all the authors for individual participant data, and then updating our hypotheses from direct prediction to interactive frameworks. Our new goal is to understand how HRV enables or disables the risk for future depression, not just predicts it. Let's proceed to the second project, exploring the association between multiple sclerosis, depression, and heart rate variability, which is a prospective observational study. Over 2.8 million people are diagnosed with multiple sclerosis worldwide. Multiple sclerosis is a chronic neurodegenerative disease, impacts the central nervous system and autonomic functions, including HRV. Approximately 30% of MS patients are diagnosed with depression, which is extremely high percentage, as in the general population, only 7% are diagnosed with depression. So this has morbid outcomes. MS patients with depression have faster progression of disability, increased physical symptoms like fatigue and pain, and lower quality of life. While lower HRV is also a predictor of both physical and psychological unfavorable outcomes. So we have a problem, as lower HRV is a symptom of autonomic dysregulation. And both depression and MS contribute to the reduced HRV. So it makes it very challenging to determine the source of the reduced HRV, whether it's the deterioration of the nervous system because of the MS, whether it's the depression, whether both of them. Okay, so our aim is to determine the source of the reduced HRV to improve the targeted treatments for these patients. So the clinical question is, does heart rate variability differ between depressed patients with multiple sclerosis compared to depressed controls? We are using the PICO framework. The population will be depressed, but half of them will have multiple sclerosis and the control group. The other half will just be depressed with no MS, and the outcome will be HRV. Our hypothesis is that patients with MS and depression will have lower HRV than those with just depression. This study will be in a collaboration with the MS clinic in Baski Shilinski Hospital. So to summarize, I have two projects. The first should end by September 2025, and the second should end by September 2026. I want to conclude with the words of Gabor Mata, who is a physician from Hungarian descent who works with trauma patients. We may not be responsible for the world that created our minds, but we can take responsibility for the mind with which we created our world. Thank you for your attention.
For your first project, I have a question regarding the HRV. You mentioned that you contacted authors for extra data. So I was just curious what data has been reported and what extra data are you planning to ask, and what you're going to do with the extra data?
That's a great question. So we written all the authors because some of them had missing data in their papers, but actually we don't just want the missing data, we want all the data. And then we will take this pooled data and we will look at the patterns of the HRV in predicting depression. So we will just use it as a bigger research than what each and every one of them did. So we didn't get as many answers as I wanted because we did offer them a co-authorship, so I thought that many people will just jump and answer us. But we do have 5 or 6 of them that want to give us their data, and that's promising, so I hope that in the next progress report I will have this big data pool to look at.
A little bit about the first and a little bit about the second project. So we are interested in multiple sclerosis patients with depression, and we want to compare it to patients with depression without multiple sclerosis. And there are different types and there are different severities of depression as well. Mm-hmm. Do you think, or is there any evidence that points to a changing association or a different correlation between HRV and different severities and different types of depression? In simpler words, if your HRV is even lower, are you at a risk of getting an even worse depression?
Mm-hmm. Okay, so I will divide my answer into 2. Okay, because I think that there are diversities in the regular population and MS patients. It's like it might be different, because with healthy physical people, like, so they are just depressed, I think there is, we can see differences in the HRV depending on different kinds of depression. So when we see more physical depression with physical symptoms like slowing down of the cognition and the body, we can see lower HRV. But then when we look at just the cognitive symptoms and like the mood symptoms, we see lower HRV but not as lower. But I'm not sure that that's what we'll find in MS patients, because in MS patients, probably, I'm not sure about that yet, but as I can see with patients, the depression is not just because of an outside reason, like they have an illness. It's clearly connected to the lesions in the brain. So I'm not sure what we'll find, and that's why we're doing this paper.
I would like to ask, do you have any data or figures on the data of the people who grew in higher adversity as children?
Okay, so I think like what I've showed here is what happened to people who have like higher adversities. So in lower adversities, we actually looked at the opposite direction, but I will show you because maybe it will be clearer. So the blue line here, it's what you can see under high adversity. So it's toxic homes, like mothers and fathers with drinking problem, like chronic illness, okay? But under good homes, or like caring homes, under good health, but majorly after, when you look at people with high emotional abilities, high cognitive abilities, you see the opposite one. So you can see that it's the exact same picture, but just the upside down. So it's good for us.